Part 4 of this lab is configuration of iOS resilience and management reporting. Cisco iOS resilience configuration feature will hide the running image. The running image is stored in NVRAM and flash memory. By hiding the running image, you will protect it from malicious attempts to erase it. The show flash command will display the running image stored in the flash memory and also subdirectories. Your output may be different in this step. The dir will show the content of the current directory. And also again, you see the running image in there as well. In this example, you see directory and subdirectories created by CCP. Now we are going to enable the Cisco iOS image resilience, which hides the file from the dir and show commands. The file cannot be viewed, copied, modified, or removed using exec mode commands. Secure boot image and secure boot config will enable this feature on the router. Now if we do the show secure boot set, we should see that the Cisco iOS resilience is activated. Now if we issue the show flash, we shouldn't be able to see the running image. The Cisco iOS resilient configuration feature can be easily turned off by putting the no at the beginning of the command secure boot image and secure config. Boot config, sorry. So now that the feature is off, you can just issue the command show flash and make sure that you can see the running image in the flash memory. So there it is. NTP is a feature used for synchronizing the time source. In this lab, R2 is the master server for NTP. So all other devices, including switches and routers, learn the time from it, either directly or indirectly. That's why you must ensure that R2 has the correct coordinated universal time set. To configure R2 as NTP master server, we use the command NTP master and the number called the stratum number. Stratum number defines the distance between the device and original source. For this configuration, we use number 3. Now that we are configured R2 as the NTP master server, we are going to configure R1 and R3 as NTP clients using the CLI. To configure R1, use the global configuration command NTP server with hostname or the IP address of the server. The command NTP update calendar periodically updates the calendar with the NTP time. By issuing the command show NTP association, we can verify that R1 has made an association with R2. To see NTP activity on R1 as it synchronizes with R2, you can use the command debug NTP all. Don't forget the configuration on R3 for NTP clients as well. We just show R1 in this configuration, but you have to make sure you configure the both sides. When you are done, you can issue the command on debug all to turn off all the debugging. This step is an optional step because if you've done the previous step using CLI, you already configured R1 and R3 as NTP clients. But we just show that how you can configure R1 and R3 as NTP clients using CCP. First, we remove the previous configuration for NTP, and then we start using CCP to configure NTP clients for R1 and R3. To be able to use CCP, first you need to enable HTTP server on the router, which is router 1 for our case. Then for the secure connection, we enable the secure HTTP server. And of course, because it's a secure authentication, we need the username and the password with the privilege 15. We also need to make sure that the authentication is going to be checked with the local database. Now on PCA, we open CCP and run it as administrator and connect to router 1. So first we put the IP address of router 1, username, and make sure you put the correct password. Then check the HTTP secure server or secure connection and click OK. And discover. Wait until the discovery is finished. When the device is discovered, click on Configure, Router, Time, NTP and SNTP server, and Add. So choose the NTP server and the IP address of router 2 because that's our NTP server. And click OK and deliver. So basically configuring the NTP server for R1. Now that the configuration for NTP server on R1 is done, and R2 is a server for R1 now, and R1 is a client, you can go back to the console of R1 and issue the command show NTP association. So you can see that R2 is a server for R1, and if you do the show clock, you get the correct time coming from R2. In this part of the lab, we are going to configure PCA as a syslog server for R1. You can use either TFTP-D32 or Kiwi syslog daemon. So first we ping R1 from PCA and verify that there is a connectivity between these two devices. Then we enable timestamp service for logging on R1. And then we configure R1 to send the log messages to syslog server or our PCA. A trap is a threshold that, when reached, triggers a log message. By using the command logging trap and question mark, you can verify the various trap level available. The default level is level 6, which is the informational messages. We are going to use level 4 for this example, which is the warnings. Then to check the current status of logging for R1, you can use the command show logging on R1 console. You can answer the question in the lab using the output of this command. We can also use CCP to configure R1 to log messages to the syslog server. To do this, first we remove the configuration we done in the previous step and start the CCP on PCA. After we logged in onto R1 from CCP on PCA, we are going to choose Configure, Router, Logging and double-click on syslog. Then we add and enter the IP address of the syslog server or PCA. We click OK. From the logging level drop-down menu, we select Warning, which is a level 4. And deselect the login buffer and click OK and deliver. Then we open the syslog server, and to trigger the trap, we turn off and on the interface on router 2. Now, if you check the syslog server on PCA, you should be able to see the warning log messages.